Hey, AB Calculus, go to the field and find a slope. On the slope, you'll find today's it's chapter 39. So, slope fields. So slope fields are easy. They look really scary, but they're really easy. I promise they're really easy. Okay, let's start doing the really easy. So we know that a derivative can be written as dy dx. Change in y over change in x. So it's a slope, right? Okay. Full circle. Whoa! All right. So when we take the antiderivative of something, there is a little bit more under the hood that's actually going on here. So we've been like, just take the integral, but we've never taken an integral with two different d thingies in it. We call them differentials. Instead, what really happens here is we multiply both sides by dx, and we get dy is equal to 2x dx. And now when we integrate this, over on the left-hand side, there was a 1 here, so that 1 dy turns into a y plus c. And then over here, we get x squared plus c. Remember, there's a plus c kind of on both sides, but we just put it over here on the right-hand side. So, the thing is, there's an infinite number of antiderivatives to 2x. And what a slope field does is it helps us see, depending on what c is, what would the antiderivative look like? So, for example, here is the slope field of dy dx is equal to 2x. Some people call it a direction field. So basically, drop a point anywhere you want, and then if we kind of do our best to sketch along, okay, that might be what that we would call this a solution curve. And so depending on where you start, you get a different solution curve. Depending on what we would call the initial condition, you get a different solution curve. So generating one of these is super straightforward. Basically all you do is, so Stu uses one of these tables. I personally struggle with these tables. I will do both ways for the first one and let you kind of pick what you want to do. It says dy dx is equal to y. So I'm going to say that these are my x values and these are my y values. Oh wait, which way does Stu do it? I'm curious. He does... Oh, he does the other way around. He has x's up here and he has y's down here. Let me do it his way. So these are my y's, these are my x's. So when x is -2 and y is 2, plug it in. Wait, there's only y in this situation, so x isn't even going to affect it. So x is -2, y is 2, so it's 2. X is -2, y is 1, so it's 1. X is -2, y is 0, so it's 0, -1, -2. And you can see that this x value, when I plug it in, doesn't do anything, but these y values do. So it's a nice table. The way that I grew up doing this, back in my day, I would do x, y, and then over here I would do dy dx is equal to y, and I would actually plug it in. So like, I would do, let's see, -2, -2, -2, -1, -2, -0, -2, -1, -2, -2. And then I would plug in -2, 2, let's see, it's 2. And I would just keep going and make a really, really long table this way. I know it is, honestly, it's more tedious to do it this way, but for some reason that works better for my brain. So 2 ways to do it, whatever's gonna work for you, totally fine. Key thing is these points, you could do an infinite number of these. What we are doing is we're doing a rough sketch, a rough version of this to show that we get it. That's all. Over here, these little dashes, there's an infinite number of dashes that we could draw. We have to draw the line somewhere and be like, okay, I can only draw so many dashes before it gets too cluttered. So we're making decisions about how many dashes to draw kind of arbitrarily. So don't worry too much about that. Like, why are we picking these points? Because that's what, we're just picking these points because we're picking these points. Let's see. So at -2, 2, my slope is 2. Hard to draw, but a slope of 2 goes up 2 and over 1. So up 2 and over 1, and that's hard, and looks like maybe like that. You could also go down 2, back 1. Okay. Oh, do a little steeper. Okay. Slope of 1. Slope of 1 is very easy. Up 1 over 1, right? So perfect 45-degree angle. Slope of 0, also easy. Slope of -1 needs to be at a -45-degree angle. And then slope of -2, make it steeper than that. So let's see, -1, 2. Wait, all of these are going to be a slope of 2. So I'll just do my best to show that it's steeper. These are perfect 45. On these, I'm kind of looking at the points here, like diagonal to it. And then slope of 0. Oop. The one slope that should have been the easiest, I messed up. And these are all slopes of -1. I don't like this as the first example because it doesn't include, like X doesn't affect it. Okay, so there's all our stuff. So then I draw the solution curve. So it says complete the table, create the slope field, show the approximate solution curve passing through the given point. Okay, the given point this time is 1, 1. So we start here and we do our best to follow it. So looks like going this way, it's increasing. Going back this way, I have to go from a slope of 1 down to a slope of 0. So somewhere in here, it's going to start flattening out like that. Okay. I know it might not look like it, but this is actually the slope field for e to the x plus c. All right, so let's look at this example. When x is -2 and y is 2, we plug those in, we get 0. When x is -2 and y is 1, -2 plus 1 is -1. -2 plus 0 is -2. -2 plus -1 is -3. -2 plus -2 is -4. I am bad at making these slopes look different from each other, but let's try it out. So -2, 2, slope of 0. -2, 1, slope of -1. -2, 2, slope of -2. So there was 1, so that's 2. That was 2, so there's 3. That was 3, so there's 4. That's the best I've ever done with that. Oh my goodness. I am so proud of myself. All right, let's see. -1, 2. You add those together. -1 plus 2 is 1. -1 plus 0 is 0. Oh, then -1, -2, -3. 0 plus 2 is 2. 0 plus 1 is 1. 0 plus 0 is 0. 0 plus -1 is -1. 0 plus -2 is -2. Let's see. 1, 2, 3. 2, 1, 0, -1. 4, 3, 2, 1, 0. Okay. So a lot of times you can pick out little tricks like that. So, excuse me. Patterns. All right, so -1, 2, slope of 1, then a slope of 0, then a slope of -1, then a slope of -2, then a slope of -3. All right. I guess you could always do that, like count up 3, back 1. And it's really hard to get perfect on these. Don't lose your mind over getting these perfect or not. Let's see, 0, 2 is 2. 1, 0, -1. And you might notice that there's like this, you know, there are these nice patterns here. So like you could even, I know that's gonna be 1, I know that's gonna be 1, I know that's gonna be 0, I know that's gonna be 0. Dot, 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 a little bit steeper, super steep. All right. So this is a wild looking slope field, but it says go through the point 1, 1. So we'll go through the point 1, 1. So it looks like to the right here, it's getting super steep. Then to the left here, somewhere around here, it's going to flatten, right? And then, start to like curve out that way. So we're just following, like we're getting steered by these. Magnetic fields are another example of slope fields. All right, let's see. Last one for this side. So 0, 2. Nope, that's the end of the problem. Let's start at the beginning. Plug in -2. So the top's going to be 2 for all of these. So 2 divided by 2 is 1. 2 divided by 1 is 2. 2 divided by 0 is undefined. Undefined. We could also think about that essentially like infinity. Like crassly think about that as infinity, because undefined slopes can be infinitely steep slopes. Then 2 over -1 is -2, then -1. So let's go through. So all these we're going to be dividing by 0. We can think about that as an infinite slope. It's really an undefined slope. Potentially, there's no potentially there's no slope there, but in this situation, there happens to be a perfectly vertical slope there. So, what about -1 over 2? Oh, no, positive 1 over 2. It's a slope of 1/2. Then slope of 0, then a slope of -1/2, then a slope of -1. And if you're like, why are you going this way now? I don't know. Sorry. 1, -1, -1/2, 0, 0, 0. So if you haven't noticed, his table is really, really good if you use the x as the top and the y as the side, because it's really showing you, like, this is the coordinate plane here. You know, over here, that's that one. Then down, it's that one. Then down, like, they're all represented in order. I really like this now. I just needed to look and see which way he did x and which way he did y. That was my only issue. I've seen the light, Stu. Thank you. So let's see, -1, then +1, then +2, then 2, then -2. No, come on, Canfield. Don't just, no, that's right. No, that's a -2. We got -2 on top for all these. -2 over 1 is -2. Negative 2 over negative 1 is positive 2, and then negative 2 over negative 2 is positive 1. Okay. Seen the light, can't do basic arithmetic. Okay, so we have a slope of 0, and then a slope of 0, and then a slope of infinity, or undefined. So I like to use vertical lines for those. Sometimes I've seen them drawn as like just blank, not there at all. I guess technically at 0 over 0, that might not be infinity, that might just be undefined, but whatever. We don't need to concern ourselves with all that. So here we got a slope of 1, then here we have a slope of 2, then here we have a slope of negative 2, then negative 1. Here we have a slope of 1/2. That's like up 1 over 2. Negative 1/2, negative 1. Slope of 1 there, slope of negative 1 there, negative 1, positive 1. Let's see, these are, what, negative 1/2? Positive 1/2. Positive 2. Oh, no, is that positive 1? No, that was right. Okay. All right. And then we get the point 0, 2. So this time we can go both directions, right? So, let me switch to my color. So we're starting out flat. Oh, we're going down. Oh. Wait, now we're vertical. Oh. Oh, look at that. Now we're getting guided back around. Up, 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 up. Oh, look at that. It's kind of like you look at it, and if you like let your eyes go fuzzy a little bit sometimes, you can see the shape that's supposed to be there. That is supposed to be a circle. Yeah. So that's the general idea of slope fields. Definitely worth your time to practice some of them. Hope this was helpful. Bye.